Now, questions on lamina become a bit more difficult when the lamina is pivoted at an angle. So the uniform lamina ABC of mass 8 kilograms is pivoted at the point A. The lamina is held in equilibrium at an angle 30 degrees to the horizontal by an inextensible string attached at point C. Find the tension in the string. So the tension here will be T. Right, so a diagram here. So what we can say is, if we take moments this way, we can say this is 3 meters, and the weight acting downward is 8g newtons, except we have to, these have to be perpendicular, so we'll have to consider that this angle here is 30 as well, the same as this angle down here, and therefore this will be 8g cos 30. So taking moments about A, so about this point here, we have 8g cos 30 times 3 meters. Those are the clockwise moments. Now we have to be careful doing the anti-clockwise moments, so we're also going to have t times 6, but we have to also consider this extra force here, which is a component of the weight, and that's 8g sine 30, because that would, where this is 2 meters, so it's that times this, and that's going to force it to go this way, which is the same as this way, which is also anti-clockwise. So that will be 8, we have to add to it 8g sine 30 times 2. Those are the anti-clockwise moments. So basically we just make t now the subject, so t will be equal to 24, 3 times 8 g cos 30 minus 2 times 8, which is 16g sine 30, divided by the 6. If we work that out on a calculator, we get 20.88 or 20.9 newtons. Now that's not the only way to do this problem. So here is an alternative solution. Now you just need to probably practice one or the other and just go with it, but here is an alternative solution to the same problem. So there we have the centre of mass, which this time I'm going to call it O. We've got a weight acting down, just made it, steadied it downwards so it cuts this line here. And AO, this distance here, will be 3, because this halfway up here is 3 plus 3 squared plus 2 squared, taking the square root of it using Pythagoras, that this distance is root 13. Now, if we, what we're going to do is do the moments around the point A, and we're going to do x times this force. Okay, so we're going to say 8g times x. We'll work that x out in a minute. That's going to be the clockwise moments, and the anti-clockwise moments are going to be this distance here times this force here, so it's going to be t times 6. All right, we haven't had to split the weight into components. However, we do need to work out what this angle is and what this distance will be. So using a little bit of trigonometry, so this angle here will be tan to the minus 1 of 2 divided by 3, which is 33.69, and therefore this will be a whole angle will be 63.69, and therefore x over root 13 will be equal to the cos of alpha plus 30, which is 63.9. So x will be root 13 cos of 63.69. So substituting that into here, we're going to have t is equal to 8g times x over 6, which is 8g times my x, which is root 13 cos 63.69, divided by 6, and that will give the same answer as before, 20.88, which is equal to 20.9 newtons. So this has been a video to show you how to find a tension in a lamina which is being held at an angle using 2 different methods. I hope you've understood, and I thank you very much for watching.